Hello, and welcome. In this video, I'm going to walk you through a Python script I've developed to download historical stock and Forex data directly from MetaTrader 5. We'll cover how the code works, how you can get it from GitHub, set it up, and run it yourself. As you can see on the screen, all the code is publicly available on my GitHub repository. You can find the Jupyter Notebook, the requirements file, and an example environment file here. I encourage you to check it out and follow along. Now, let's talk about how you can get this code from my GitHub repository and run it on your own machine. First, you'll want to clone the repository. Open your terminal or command prompt and use the git clone command followed by the repository URL I showed earlier. Once it's cloned, navigate into the project directory. Next, you need to install the required Python libraries. I've included a requirements.txt file that lists all the dependencies. You can install them easily using pip install our requirements.txt. This will install MetaTrader 5, Pandas, NumPy, and python-dotenv for you. Alright, let's dive into the code itself. I'm using a Jupyter Notebook here, which makes it easy to run and explains step by step. First, we import all the necessary libraries. MetaTrader 5 as MT5 for interacting with the MT5 terminal, datetime, time zone, and time delta for handling dates and times. OS for interacting with the operating system, like creating folders. Pandas for data manipulation and creating data frames. NumPy for numerical operations, especially for concatenating data arrays. Time for adding small delays between API calls, which is good practice. And load_dotenv from the dotenv library to manage our API credentials securely. Next, we specify the path to our environment file, which we'll discuss in more detail shortly, and load it. Then, we load our MetaTrader 5 account credentials, the account number, password, and server, from the environment variables. This keeps sensitive information out of our main codebase. Here in the configuration section, you can customize the script to your needs. Symbols_to_download. This is a list where you can specify all the currency pairs or stock symbols you're interested in. For this demo, I've set it to USD/JPY and USD. Request_timeframe. We're requesting daily data here, indicated by MT5 timeframe_D1. You can change this to other timeframes like H1 for hourly, M1 for minute data, etc. Start_year_data. This defines how far back you want to fetch the historical data. I've set it to 1990. Output_data_folder. This is simply the name of the folder where our downloaded CSV files will be saved, which is stock_data. And API_call_delay. A small half-second delay between API calls to be polite to the server. The script then defines the path to your MetaTrader 5 terminal 64.exe file. Important, you'll need to make sure this path is correct for your own MT5 installation. Following that, we have crucial error handling. The script checks if the environment variables were loaded correctly and if the account number is a valid integer. Then, it attempts to initialize the connection to MetaTrader 5 using MT5 initialize. If it fails, it prints an error and quits. Once connected, it creates the output data folder if it doesn't already exist using OS makeDirs. The core of the script is this main loop that iterates through each symbol_code in our symbols_to_download list. For each symbol, it prints which symbol and time frame it's currently processing. It attempts to get and print some basic information about the symbol, like its description. Then, it enters another loop, this time iterating through each year, from our start_year_data, 1990, up to the current year. Inside the year loop, it defines the date_from_year, January 1st of that year, and date_to_year, December 31st for past years, or the current date and time for the current year. It then calls MT5.copy_rates_range with the symbol, time frame, and the date range to fetch the actual price data. This function returns the data as a NumPy array. A small delay is introduced. The script checks if data was retrieved. If so, it appends this chunk of data to our all_rates_for_ symbol list and prints how many bars were fetched. If no data is found for that period, or if an error occurs, it prints an appropriate message. After processing all the years for a particular symbol, it checks if any data was actually retrieved for that symbol across all years. If data exists, it uses np.concatenate to combine all the yearly NumPy arrays into one large array. This combined array is then converted into a Pandas data frame. A critical step here is converting the time column from Unix timestamps, which is what MT5 provides, into human-readable datetime objects using PD_datetime. We also make sure they are UTC. The data frame is then sorted by time, and any duplicate entries are dropped, just in case. Finally, it constructs a CSV file name and saves the data frame to that CSV file in our output_data_ folder. This process repeats for every symbol in your list. After all symbols are processed, the script shuts down the MetaTrader5 connection using MT5 shutdown. Before you can run the script, you need to set up your MetaTrader5 credentials. For security and good practice, we use an environment file for this. In the repository, you'll find a file named env.example or environment.env.example.txt as shown here. You need to create a copy of this file in the same directory and name it exactly env or environment. env. The script is currently configured for environment env. Let's open this example file. You'll see it contains placeholders for 3 keys. MT5_account_number_demo. This is where you'll enter your MetaTrader5 account number. MT5_password_demo. Here, you'll enter the password for your MetaTrader5 account. MT5_server_demo, and this is for the server name of your MetaTrader5 account. You should have received all these details from your broker, like Vantage International, as indicated in the script's MT5 path, when you signed up for your demo or live MT5 account. Typically, these details are sent to you via email. Carefully copy and paste them into your environment env file, replacing the placeholder text. Make sure to save your environment env file after entering your details. This file is included in the gitignore file in the repository, which means Git will ignore it, and your sensitive credentials won't be accidentally uploaded if you decide to commit changes to your own fork of the repository. With the dependencies installed and your environment env file configured with your MT5 credentials, you're ready to run the script. In the Jupyter Notebook, you can run each cell individually by selecting it and pressing Shift+Enter, or you can run all the cells from the Cell menu by selecting Run Alt. As the script executes, you'll see output messages in the notebook, indicating the connection status, which symbol and year it's currently processing, and how many data bars are being retrieved, or if any errors occur. Once the script has finished running for all the configured symbols and years, it will have created the stock_data folder, if it wasn't there already. Let's take a look inside. As you can see, we have our CSV files. Here's the file for usdner_D1_1990_to_2025 CSV. If we open it, you can see the columns: time, open, high, low, close, tick_volume, spread, and real_volume. The time column is nicely formatted as a readable date and time. And similarly, here's the data for USDJPY_D1_1990_to_2025 CSV. It contains daily price data from 1990 all the way up to the current year the script was run in, which for this example is up to 2025. This provides a comprehensive dataset for analysis. So, to summarize, this script automates the process of connecting to MetaTrader5, fetching historical price data for multiple symbols over many years, and saving that data into clean, usable CSV files. It's designed to be configurable and includes error handling to make the data collection process smoother. This is incredibly useful for anyone looking to perform backtesting of trading strategies, conduct market analysis, or for any data science projects involving financial market data. Thank you for watching this walkthrough. I hope you found it helpful. You can find all the code, including the Jupyter Notebook and supporting files, on the GitHub repository linked in the description below. If you have any questions or suggestions, please feel free to leave a comment. Don't forget to like this video if it helped you, and subscribe to the channel for more tutorials and coding projects. Happy coding!